All right, this video will go over the chapter 1 through 3 final exam review. And there we go. So you're going to identify each statement as true or false. The three undefined terms in geometry are point, line, and plane. So angle would be false. In a linear pair of angles, one of the angles must be obtuse. It usually is, unless you have two right angles like you see there. And so that would be false. Trapezoid has exactly one pair of congruent sides. And so in that case, you're looking at an isosceles trapezoid. But what if it's not an isosceles trapezoid, right? Then it wouldn't have one pair of congruent sides. And so that would make that statement false. A semicircle is a half circle. So that's going to be false. The arc measure is actually 180. A scalene triangle has no sides the same length. That is true. If a point is on the bisector of an angle, then it is equidistant from the sides of the angle. Is also true. And to do that, you can go ahead and just draw a random angle. I'll make mine about 30 degrees. And the bisector of that angle would be right around 15 degrees. It's going to be bisecting it, meaning it's an angle bisector, kind of like that. And it says that is equidistant from the sides of the angle. So that's going to mean that the distance here is same as the distance here. And it turns out that it is. Those are the same. And so that's going to be true. Next one is only one plane can pass through one line and a point that is not on the line. And so that's an example of saying if you have a line, I'll just draw this, and a point not on the line. And again, so a line goes infinitely in all directions, that the plane, imagine the plane's a piece of paper. It has to completely cover the entire line. And so you can imagine that you can kind of turn the plane so that it covers the entire line, but it also has to go through that point. So the answer to that would be true. There's only one plane. We can't change the plane and it still go through the entire line at that point. So that's true. Square is both a rhombus and a rectangle. It's also true. So a square is it's equiangular, which makes it a rectangle. And because all sides are congruent, it's also equilateral, which is the property of a rhombus. And because it has the properties of the rhombus and rectangle, it is a rhombus and rectangle. So that's true. Centroid of a triangle is the center of gravity for the triangle. That is true. The process of observing data, recognizing patterns, and making generalizations about those patterns is inductive reasoning, not deductive, so that's going to be false. ABC has vertex, should say B, not C, so the vertex is the middle angle, right? So in this case, you would have A, B, and C, right? So B would be the vertex. And two lines are cut by a transversal to form a pair of congruent corresponding angles. Then the lines are parallel, right? So two lines cut by a transversal. If they form a pair of congruent corresponding angles like this, then yes, the lines have to be parallel. That's a conjecture from chapter 2 called the converse of the parallel lines conjecture. Next is when you construct a figure, you use only a compass and a straight edge. Don't use a protractor in doing constructions. So that would be false. Tangent to a circle is a special type of chord. No, a tangent looks like this, hits it at one point like this. A chord is a segment whose both endpoints are on the circle. That would be a chord. So a diameter would be a chord, for example. So that's going to be that false. The incenter of a triangle is the intersection of the angle bisectors, actually, not the perpendicular bisectors. And so, like a visual of that if you have a triangle and you draw all of the angle bisectors, then where they intersect is the incenter. What's special about the incenter is that if you draw a circle that hits all three sides, so it's tangent to all three sides, the center of that circle is going to be the incenter of the circle, of the will be the incenter. Okay. Part B. I'm going to complete each statement. So an acute triangle has angle measures that are all less than 90. A diameter is a chord that passes through the center of the circle. If angle 1 and angle 2 form a linear pair, then the measure of angle 1 is 64, and the measure of angle 2 will be 116. It's 180 minus 64. The incenter of a triangle is the center of a circle inscribed in the triangle. That's just what you saw up here, where you have a circle inscribed in a triangle so that it hits all three sides of the triangle. The center is called the incenter. Each point on the perpendicular bisector of a segment is equidistant from the endpoints of the segment. So that is saying that if you have, these are the endpoints of the segment, we'll call them A and B. And a perpendicular bisector is in the middle and it's perpendicular, and each point on it is equidistant from A and B, meaning that if you were to draw a triangle here, triangle would be isosceles, right? So that the there's that side. Well, this distance is the same. That's what that's saying. And 6, 7, 8 are crossed out, but that actually shouldn't be crossed out. Those are fair game for the final. So a translation 6 minus 4 followed by a translation minus 3 minus 5 is equivalent to what? Well, basically you're going to add the x's together. You get 3. 6 minus 3 is 3. And then add the y's together. So minus 4 and minus 5 is minus 9. Another way to write this is x plus 3, y minus 9, right? So when there's the sharp brackets, then you just have the numbers, and if it's a regular bracket, you put the x plus 3, y minus 9. Okay. Line of reflection is the blank of every segment joining a point in the original figure with this image. So the answer is perpendicular bisector. Now, why is that? Well, if you have a line of reflection and then you have its original point, let's call it A, and you reflect that line over you reflect the point over the line, meaning you fold it, that point's going to land right here. We'll call that A prime. And then you can kind of draw a dashed line segment in between it. Okay. So the line of reflection is going to bisect it because the distance is the same, and it's going to be perpendicular to it. So that's going to make it the perpendicular bisector of the line segment that joins A to A prime. Okay. So the original figure is like A, and its image is like A prime. Okay. The ordered pair rule, xy leads to what? Represents a reflection over the x-axis. Well, if you have a coordinate axis, and let's say you have an x-coordinate, I have a point up here, and if I reflect it around the x-axis, then it's going to be down here, right? Now, let's say the coordinates of this is x is 2, y is, let's say, 3. If I reflect it, then the x-coordinate isn't going to change, but the y-coordinate will be opposite, right? Because the distance from here to the x-axis is the same as the distance there, right? So these are the same distance. So the y-coordinate changes sign, the x-coordinate is the same, and so that's going to be same x value and opposite y value. Okay. Next is lines L and M are parallel. Find each lettered angle measure. So first of all, we can find that these are parallel. So let's go ahead and mark them parallel. I'm starting out with 70 degrees down here, and I know that A is what's called an alternate exterior angle to 70, so A is 70. And B is just going to be 180 minus 70 minus 42, because they all lie on this line right here. That's going to be 68. And then you can do a similar way to find, well, C would be 42 because of vertical angle right here, right? These are vertical angles. That makes C 42 degrees, and D is, right, this is 68. And one of the ways to do it is to know that these two angles right here are supplementary. Always, they add to 180, and that will make it 138. And mark this here as 70. The other way to do it is to know that this angle corresponds to that angle, because that angle is 70 plus 68, which is 138. D would be 138. That's going to make E42, linear pair. F is 138. Again, vertical angle G is going to be 70 because it's alternate interior angle with that 70. And then H is linear pair, so that's going to be 110. There we go. Okay. So looks like we have 1, 4, 9, 16, 25, and these are all perfect squares. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, so that would be 6 squared, 36. 10, 9, 7, 4, 0, so 10 minus 1 is 9. 9 minus 2 is 7. 7 minus 3, so every time we're subtracting one more. So 4 minus 4 is 0, and then 0 minus 5 is minus 5, so we go minus 5 minus 6 to get minus 11. All right, 3 and 4. I've had a lot of questions on those, so I'll go through this pretty slowly. If the rate of change is constant, then you will solve it this way every time, right? Because a constant rate of change, if you think back to algebra, is called linear, right? You get a linear equation where y equals mx plus b. M is the slope, b is the y-intercept. Now, in this case, it's not using those letters. Instead of an x, you have an n. And rather than writing an equation, we're just going to write an expression. So there's an n there. Okay. And we're not going to use, and what we need to do is need to find m and b. So we need to find the rate of change in the starting value. So the rate of change is how much it changes every time, which is 3, right? It goes up by 3. So that's going to be 3n plus the starting value. Now, it looks initially like the starting value is minus 5, but if you think back to linear equations, where these are your x, y axes, the starting value is where it hits the y-axis. That's the y-intercept. And that's where x is 0. So we need to go back to term 0 and find what that is. And because we're going up by 3, to do that, that would go back to minus 8. So plus a minus 8, which is the same thing as 3n minus 8. So that's why I wrote that there. The rate of change in the next one is what? Well, rate of change, again, it's going down this time by 11, so minus 11. And the starting value number is not 6. You go back to term 0, which if you go back 11, you'll get to 17. So minus 11m plus 17. And then we get to how many diagonals does the 32-side polygon have? Well, if we kind of simplify this model, let's say we have 1, 2, 3, 4, 5. Let's look at a 5-side polygon. And let's ask how many diagonals does it have? Well, 1, 2, 3, 4, 5, 6. So 6 diagonals in that case. How do we get that? Well, we look at the number of vertices, which is 5, right? So 5 vertices. And each vertice has 2 diagonals. And if we get that, we get 10, but we know we didn't get 10. We got 5. Did I say 6? I should have been 5. Should be 5 diagonals. And so we need to divide by 2 so that we don't double count and we get 5, right? So this is going to be n minus 3, and then divided by 2. Now, why n minus 3? Because we're not going to count this one, and we're not going to account this one, and we're not going to account its own vertex. And so it's only going to have 2 things coming out of it, even though there's 5 vertices total, right? Because it's not going to go to this vertex, it's not going to go to this vertex, and it's not going to go to that one. It's only going to go to 2 vertices out there, okay? So you're going to subtract 3 of them from it. In the case of 32, where it's the same idea, where you have 32 vertices because you have 32 sides, but you're going to, so every vertice will have n minus 3 diagonals coming out from it, because again, you're not going to count the 2 next to it, and you're not going to count itself. And so you'll go 32 times 32 minus 3, and then you'll divide it by 2 so you don't double count. Another way to solve it, which I told you guys in class, was you can actually go n minus 1 over 2, which if you recall, this is another way of doing it. This is the formula for the number of handshakes, right? So if imagine we're doing a handshake problem. There are 32 people in a room. How many handshakes are there? Well, 32 people are going to shake 31 hands. So if you go around the room, everyone will say, well, I shook 31 hands. So 32 times 31. So how many handshakes were there total? Well, if I shake someone's hands and they shake my hand, then we need to divide by 2 so we don't double count. So that should be 1 handshake, not 2. So that's why we divide by 2. But we're only doing the number of diagonals, right? So we don't want to include the sides outside. So we need to subtract n, subtract the number of sides, because that will leave us the number of diagonals left. So that's actually, if you do some algebra, that's actually equal to n minus 3 over 2. So they're the same thing. So you can do it either way. You'll get the same answer. Okay. So with part E, we'll have some basic construction questions on the final. And so you should know how to do perpendicular bisector and the other basic ones we've done. Nothing too complicated, but there will be on there. So number 1, it says to draw a segment PQ. And let's go ahead and draw it. And then you're going to construct a perpendicular bisector. So the way to do that is to put your compass on one of the endpoints, adjust it so that it's a little bit more than halfway, and then you're going to swing an arc, keep the adjustment the same, swing the same arc, and then draw a line down. And that will give you, I didn't do it with a compass, but it should give you perpendicular bisector, okay, of P and Q. Okay. Next, it says to construct triangle XYZ, so X is 90 and Y is 45. So to do that, well, again, we're going to line segment, and swing an arc, connect it. We have a 90-degree angle. So how do we get a 45? Well, you could do an angle bisector of that and you get a 45. Then do another perpendicular bisector. That would work. But remember, if we have a 90-degree angle and this is 45, then the other one would have to be 45. So really what we are having is a right isosceles triangle. So if I just set my compass right here and then swing an arc up here and then swing the same arc down here, that's going to make these sides congruent, which will make it isosceles. And then all I have to do is connect these together, and I'm automatically going to have both of them be 45 degrees. Okay. So the next thing is to duplicate a triangle. And so let's go ahead and get a triangle made. I believe it's ABC. Also, the triangle right here, ABC. Duplicate that. So the way to do that, again, I'm just going to start by labeling a point. And I need to, let's see, let's just draw a line segment out here. And then I'm going to take my compass, set it at B, draw an arc at C, draw the same arc out here, and label a point. So I've duplicated that angle, right? So these are now congruent to each other. And we'll do a side angle side one. So we use SAS to do it. And so I'm going to duplicate. So I have a side here. I'm going to duplicate angle B. So set my compass at B, swing an arc of any side I want, come over here, set the compass at this point, swing the same arc. And then I'll come back over here and put my compass right there, swing an arc. So I hit that point right where they intersect, come over to this point, swing that same arc, and then just bring your compass over and get there. Remember, there's the Math Open Ref resource that you can use to look up the constructions as well. So side angle side, right? So side, I have an angle, and then all I need to do is another side. So I'm going to go ahead and come over to point B again, measure to point A. So I swing that arc, come over here, I'm going to swing the same arc, and then I have duplicated the side, the angle on the side, so I know they're congruent. And so just come over here and connect them together, and I have duplicated the triangle. There you go. So that's the third one. The fourth one says, draw RS and construct a line parallel to RS. And I really like this one because it kind of goes over the converse of the parallel lines conjecture. So if I have a line here, I'll call this, so I have a line, and I have R, and I have S. And if I construct a line parallel to RS, that means that if I have a transversal, right? If I have a transversal, I'm just going to sketch it first. So if this lines truly are parallel, then that means that corresponding angles are congruent, or alternate interior angles are congruent. I'm going to use corresponding. So if corresponding angles are congruent, then the lines are parallel. So all I need to do is duplicate the angle up here. I have to duplicate this angle, and I have a line parallel to it. So I'm just going to draw a random point and use that point to duplicate my angle. So come down here, swing a random arc, come over here, swing the same arc, and then I'm going to set my compass right at that point, the other compass there, and measure it, and swing an arc there, and then put one end right here, swing an arc right there, and I've duplicated that angle, which means these lines are going to be parallel to each other. Okay, there we go. Finally, and this does, I believe, said optional, but that was these are not optional in the sense that these are both fair game questions for the final. So do them. So the first one, you'll notice that in this problem, the orientation of the triangle hasn't changed, right? So it hasn't turned or twisted or flipped at all. So in that case, it's going to be a translation. All I'm doing is moving it. And so I'm going to be moving it to the right by a certain amount and down by a certain amount, right? So I'm moving it to the right by 1, 2, 3, 4. So x, comma, y is going to lead to x plus 4. It's to the right 4. And then down 1, 2, 3, 4, 5. So y minus 5, so down 5. That would be your rule there. Another way to do these problems is just to start with a, and to list out the coordinates of a is minus 5, 4, and then look at a prime and list that out as x coordinate minus 2, y coordinate minus 1, okay? So if it is a rotational reflection, then the numbers are going to be the same, but since all these are done about the origin, but they'll just either flip places or they'll flip signs. So if we see different numbers here, it's typically going to be a translation. Whereas down here, I'll show you what happens here. This is a, so a is minus 4, 3, and a prime, we can see, is 4 minus 3. So you'll notice how in this case the numbers didn't change. All that changed was the sign, right? So if you have x comma y, how does it change when it goes from a to a prime? Well, if I'll just write that down here. Well, it looks like x and the y are in the same location, but the x changed sign, so we put negative, but negative just means opposite, right? Notice how 4 is a positive number, right? So it doesn't mean the number itself is negative, it means opposite. So whatever x was, it's now opposite. So negative 4, opposite negative 4 is 4. And then with y, because it's 3, opposite 3 is minus 3, all right? So we put minus y there. So that's your coordinate rule. Is it a reflection? What is it? Well, this is going to be, if it was a reflection, it could be a reflection with the line y equals x, but you can imagine if you fold it, then the shape would look more like this, wouldn't it, right? More like that. So it's not a reflection about the line y equals x. The only thing left is a rotation. If you take some patty paper and trace it and turn it 180 degrees, it'll land right there. So this is going to be a 180 degree rotation. And there we go. The one above would be, again, translation. It's to the left by 4 and then down 5. Okay, there we go. So that concludes Chapter 1 through 3, final review problems.